So I'm going to show you the derivative of this graph. So you guys can probably not see. So let me show you this part. Wait. Okay, so what happened is if you have something like this, and I'm gonna show you the graph of f prime of x, so you guys gotta pay close attention. Okay, very very close attention because it's really easy to miss it. So I'm gonna go to here, and I'm gonna say it's f prime of x graph. So I supposed to be able to see that f prime of x graph. Hold on a second. It doesn't do that. So hold on, maybe here, shift prime of x, right? Do you guys see it? No, you didn't pay attention. I'm going to show you again. I'm going to grab double derivative. So you can see it? It's the same damn graph, Jesus. You just missed it. You missed the graph. See, I grabbed this first derivative. Look. If I unhighlight it, right? This is e to the x graph. This is a blue one, which is e to the x graph, which is the green one, e to the x graph. What is that implying, though? What is that implying? That means implying derivative of the ex is what? Derivative of e to the x is what? Yeah. See, this is like probably the most difficult thing you ever learned. It was so hard. I don't know. We're gonna have a test like 2 months later. Okay, so derivative of e to the x is e to the x, and I'm gonna show you foundationally this is what actually happened. So this is y equal to e to the x. And how do I take a derivative of this? If I say let's choose a different route to take a derivative of this, let's choose the other way that we learned yesterday or on the last test. What we're supposed to do before we take a derivative? ln. You can do ln on both sides. Good. So I'm going to do ln on both sides. So I'm going to do ln. And what happened to e to the x? Here is going to be e to the x, right? Now what happened is ln and e, they are what? They are inverse to each other. If they're inverse to each other, they will turn into just x. And it's going to get ln of y. And now we're going to take a derivative of this, right? So what happened when we take a derivative of this is going to be y prime over y. Hopefully you guys did that in yesterday's test, which is y prime over y. You should write that down because that's the derivative of natural log of y. And derivative of x, that's going to give me 1. And voila, y prime is equal to y, which is also equal to e to the x. Do you guys see that? Because derivative of x is 1. Genius. Got it? It's actually pretty cool. Like, it's a very simple proof to prove that.
Please release your students for B1.
So it turns out derivative of e to the u, it's a little bit different because there was a chain rule. So don't make mistake, there was a chain rule occur. So chain rule, you have to pay attention to chain rule all the time. So that means if I take a derivative of this, it's going to give you e to the u. It looks exactly alike, but there was a du dx afterwards. You got to take a derivative of that u. Or sometimes people say e to the u, u prime. Either way, it's fine. Okay? So what do you think derivative of e to the 3x?
E to the 3x times 3.
Perfect. And that's it. It's not e to the 3x. It's e to the 3x times derivative of 3x, which is e to the 3x times 3. Can I take a derivative of this? E to the 2x times x squared? Is it possible to take a derivative of this? What do you think a derivative of this? What do you see?
You do e to the 2x times 2x plus, and then you do 2e to 2x.
Something's missing.
E to the 2x times 2x.
No, that's wrong completely. So there's a product rule. Good. So you should see there's a product rule here. So that's going to be, well, first I'm going to take a derivative of e to the 2x, which is 2e to the 2x. Does that make sense? And times x squared. Does that make sense? Plus e to the 2x times 2x. Does that make sense? So that's going to be 2x squared e to the 2x plus e to the 2x times 2x. Now you can factor out x and you can factor out e to the 2x because sometimes it's going to help you find, let's say, critical points or maximum minimum. That's something you have to worry about in a second. So that you can take out x here. So that's left with the 2x and plus 1. So sometimes you will have some type of minimums and stuff like that you have to pay attention to. So in this case, it's e to the 2x times x times 2x plus 1. I can factor out because once you factor out, you can solve for critical numbers, right? 2x plus 2. I can add. Good job. That's why a student like you to correct my mistake. Questions? Now, I'm going to ask you to combine yesterday's knowledge and today's knowledge. You're like, whoa, it's too much. So yeah, I can do this. So let's say y equal to natural log of 1 plus e to the 2x over 1 minus 1 plus e to the negative x. So I want to take a derivative of this one. You guys want to give it a try? If you're done, you can check it another person, see what they get. First, do you do calculus? You don't do quotient either. Good. You can, using the logarithm property. Remember, always think of algebra before you do calculus. Does that make sense? So can I do this? Natural log of 1 plus e to the 2x, right? Minus natural log of 1 plus e to the negative x. Did I do any calculus? No, I just do pre-calc. Algebra 2, even. And let's take a derivative of this. So the derivative of this one, I'm going to get dy dx is equal to what? What's derivative of natural log of something? 2e to 2x? What else? Over what? 1 plus e to the 2x. Does that make sense? U prime over u, right? Minus, right? Now, what's derivative of 1 plus e to the negative x? Negative e to the negative x over 1 plus e to the negative x. Does that make sense? And since there's two negative sign, can I change it to positive sign? And that's going to be a positive sign right in between. So it was two negative sign. I change it to positive sign. And that's my derivative. Wow, is it hard?
Wait, when you take the natural log,
Is this hard? Pretty easy, right? Do you guys know how to do it now? So you just learn how to take a derivative of e to the x. Okay. And also combine with last week's knowledge, because we're using logarithm properties. Okay, so what else we can do? Well, we can give you other questions. Let's just say, for example, if we can ask you implicit derivative as well. Okay, so let's just say if I have this function, I don't even know if this is a good function, but I'm just gonna try to ask you to take a derivative. So plus ln of x y squared equal to negative 3x squared y, something like this, and say, hey, I want to take a derivative of this. Now, what do you have to do first here?
do you split up the log function of x and y?
What'd you say?
Do you like expand
Expand where?
the log x x y squared?
Exactly. How do I expand them?
Or you do log x plus log y or 2
Plus 2 log y, right? Yeah, so you can expand that, but what happened at the result is going to probably give you a 2 times natural log of x plus 2 times natural log of y. Does that make sense? Because you put a 2 in the front,
Wait,
the 2 is going to distribute that to both.
is it like parentheses around x and y? Because I assume that only applies to y. Am I wrong in assuming that? I asked because there's a question I give on the test.
Yeah.
Oh, yeah. I make a mistake. Yeah. So that's a natural log of x plus 2 natural log of y. And then is equal to negative 3x squared y. So now I split this up. I don't know. I have brain fart. So now I'm going to take a derivative of this. So how do I take a derivative of this? How do I take a derivative of e to the xy? That's the hardest part. What do you think derivative e to the xy is? Can somebody help me?
E to the xy?
No. It's x times y. They're times each other. That means what? Product rule and chain rule, right? So e to the xy, first of all, you had to write that first because derivative of that is going to be e to the xy times the y times the u prime, right? U prime is going to be 1 y plus x dy dx. Does that make sense? Because there is a product rule. Don't forget that. And plus 1 over x plus 2 natural log of y, which is natural log of y is y prime over y, which is dy dx over y equal to minus 3. There's a product rule here again, so it'll be 2x y plus x squared dy dx. Does this make sense? Let me know if you have any questions here. Are we okay? Now, can I distribute that? Yeah. E to the xy times y plus x e to the xy dy dx plus 1 over x plus 2 dy dx over y equal to negative 6xy minus 3x squared dy dx. So all the dy dx term I'm moving to the right. So I'm moving to the right, and also factor out dy dx. So I'm going to get dy dx here. If I factor out, it's going to be negative 3x squared minus 2 over y and the minus x e to the xy. Does that make sense or no? Or am I going too fast? And now just move to the other side. So I moved all the dy dx to the right hand side and factor out dy dx. I kind of do two things at one step. And I'm going to get dy dx here. That's going to be e to the xy times y plus 1 over x plus 6xy all over negative 3x squared minus 2 over y minus x e to the xy. And you look like this question is very, very complicated. But really just chain rule and product rule on all of them. I can multiply top and bottom by xy, just make things easier. And so that's going to be xy squared e to the xy plus y plus 6x squared y squared over negative 3x to the third y minus 2x minus x squared y e to the xy, and that should be the final answer. Any question of what I did that you don't understand?
What did you do from the right to the blue at the last thing?
Yeah, because they are all complex fraction. There was a something over x and something over y. The best thing is to multiply top and bottom by xy, because essentially I multiply by 1. And then, so what happened is x will cancel out that x, will left with the y, and y would cancel on the bottom, left with the x. And everything else is going to add it to xy term, or going to multiply the xy term. Darby, do you understand? Yes? Yes, so sure?
Yeah, I'm good.
Okay. See ya?
Yeah.
All right. So we finished the derivative. We're also going to talk about integration. So don't get confused with derivative and integration. Today you're going to have both. And they both are a little bit different. So this is the question that we're going to be dealing with, which is, what is integration e to the x? What do you think? Very hard. Missing something. Part C. Okay, good. What is integration e to the u? Now this one's a little bit different though. This one is you have to be careful. Be careful with this, because there is a. Be careful here. I always told students to make sure to be careful, because e to the u, because this is a u substitution. U sub. Every time you have a u sub, there is a du and dx, right? There's something that you had to pay attention to. So what do you think integration e to the 2x is? What do you think? What's the integration e to the 2x? Nope.
Number 2 plus C.
Nope. Remember, guys, u substitutions. What is u equal to in this case? 2x. Not just 2, but 2x. So what is du? And what we always do when we get to this point, we solve for dx, right? Did you do that? Okay, so now it's going to be integration e to the u. Dx is equal to du over 2. Now, what's the nice thing? There's a constant. You can take it in the front. They are best friends. And it's going to be 1/2 e to the 2x plus c. Does that make sense? If you don't believe me, take a derivative of this. Now you know how to take a derivative chain rule. The derivative of 2x is equal to 2. 2 times 1/2 is equal to e to the 2x. That go back to before, which is that makes perfect sense.
The integral of e to the u is just e to the u.
Yeah. And maybe I should write that down. But it's e to the u though. And you have to make sure everything in terms of du, that's a problem. Are we okay here? Okay, so I'm going to combination a couple different ideas. Remember, you should do algebra first. If you see any rule that can help you reduce a problem, you want to do it. So, but before that, I'm going to show you something though. Let's say e to the negative 2x, okay, and the sine of 3x. Let's integrate those. Now, you see that this is x to the first power. Do you see that? And you see this x to the first power? They have commonality. Is it u equal to negative 2x, right? And this one u equal to 3x. They are the same process. Do you see that? And you're going to say du is equal to, am I going too fast? Du equal to negative 2 dx here. And this du equal to 3 dx. Does that make sense? And end up the negative 2 is always moved to the front. So it'll be e to the u and du over negative 2. If you realize that's going to be always reciprocal of that u substitutions, it's always 1 over, assume that this negative 2 is a, is a 1 over 2 e to the u. That's pretty much it.
I have a question.
Sure.
So like, what if instead of like being negative 2x, what if it was just like negative x? Would you still use the substitution?
You still use u substitution, then that one's going to be negative e to the negative x. You're still going to have a negative sign. That's a great question because u equal to negative x, du equal to negative dx. And if you pay attention, this is not so different. This is just 3 moved in front. It's 1 over 3. Because if you think about it, does that make sense? By understand by correlations? And you're not doing that extra unnecessary u substitution anymore. You can just say, oh yeah, since x to the first power, you can always 1 over 3 and derivative of the cosine is equal to sine. So that must be negative cosine of 3x. And that's plus c. I don't even need to use substitution anymore. I can do it a shortcut inside my head. Are we okay here? Am I going too fast? Okay. So what we're going to do is asking you to do this one. This one is going to be interesting because it's a combination of all the things that we learned. Okay, so how do I take a derivative of this?
Would you use long division?
What?
Would you use long division?
No. It can be done, but no. It can be done, but no. What's the best way to do this? Think algebra. How would I do algebra here?
Would you split the like e to 3x over e to the x?
Yeah, because that make your life easier, right? That's just too many e's. E to the 3x over e to the x. Can I write like this? And the middle term actually pretty easy. Does that make sense or no? And then can I just change it to e to the 2x minus 1 minus e to the negative 3x dx? Yeah, it turns out like a very beautiful integrations that actually don't need to do some complex rule, use substitution, and all that. And then that's going to be, well, according to that, what's integration e to the 2x? What did we learn earlier, the shortcut? What is it? Yeah, so it's what? Yep. And that's not what Ani says, right? Ani says 2, but it's actually 1/2. Because u equal to 2x, du equal to 2 dx. If you solve for dx, you got 1/2 in the front. Does that make sense? Are you sure? And minus x here, integration of 1 is x. And what's the next one? What do you think integration of negative e to the negative 3x is? 1/3 is plus because it's both negative and plus. So it'd be like this. Does that make sense? Now we're going to give you a test about u substitution. Let's think about what you need to do here. If I have e to the x over here, 1 plus e to the x, how do I do integration of this one? And also there's a boundary. Let's do a natural log of 4 and natural log of 2. How would I do integration and with definite integral? Now remember, change boundary. Always something very helpful. How do I do integration on this one? Any good ideas?
So
Okay, what would u equal to?
1 plus 3 but yeah,
Why?
because the bottom denominator has the same, what is the coefficient or exponent as top?
Yes. U equal to 1 plus e to the x. And one nice thing is after you take a derivative, 1 goes away, right? And then what happened? We can take a derivative of this. Guess what? Every time you said u equal to something, always has to be within the problem. So in this case, e to the x dx is within the problem. So I can technically just change that to u. But I don't do that. I'll do it the longer way. And that way you can see it a little bit better. So that's going to be integration of what? E to the x over u times du over e to the x. E to the x cancel out. Now, natural log of 4. 1 plus ln e to the ln of 4 is what? Yep, 5. And this is 4. Okay, so this one is going to be 5 and 4. So integration 5, 4. Guess what? It's natural log of 5 over 4.
So would it be 3 instead because it's 3 plus 1?
Oh, I cannot do math. 3. So 3, so it'll be natural log of 5 over 3. And that's it. Now, does it need absolute value? No. Yeah, positive. If they're negative, yes. Does this make sense? So sometimes your boundary can switch the bound, but just sub in the bound.
Why is it log 5 over 3? Am I missing something?
Yeah, because of the natural log of 5 minus natural log of 3. If subtraction is division.
Would you still have the plus C even though it's a definite interval?
Oh, yep, you're right. There's no definite equal. Nice catch. Are we doing okay? Do you understand or no? Pretty good? Okay, you're gonna do this one. This one's kind of related to your last test. And because we had test review like this, I think it was x to the 1/3, derivative of x to 1/3 is equal to x to the negative 2/3. And a similar relationship here. Remember, told yourself is set u equal to, you always think of du at the same time when you do think about u is equal to something. Now du has to be within the problem, can help you simplify things. Remember, u equal to something, du has to be within the problem. Usually that 1 degree difference help you. For example, 1, -1, you subtract 1, it's going to give you -2. But if you have something to the half degree, if you subtract it, it's going to give you -half. What does u has to be here? Yes? Shang? Perfect. U equal to square root x, and then we're going to straight x to the 1/2. Now, why do I do that? If I take a du is equal to 1/2 x to the -half dx, so that's going to come up pretty nicely. Now, I write it like this always, and I solve for dx always. So it'll be e to the u over 2 square root of x. Times square root of x. I think I write down the 2 on the wrong side. This one is this. This one's 2 square root x dx. So this cancel out. So it'll be 2e to the square root of x plus c. That's my final answer. Does this make sense? So today's homework, you're responsible for integration and derivative at the same time.
If the square root of x is u, then wouldn't the denominator also be u?
Yeah.
What?
Well, they cancel out. Square root of x and square root of x cancel out.